Okay. So today we will be doing lab 7, improper integrals. Okay. So as I said you, this lab is going to be a short lab and you have only 13 problems to solve. So from question 1 to question 12, you can solve this using direct integration, integration by parts, or use substitution. And remember, you have to upload both MATLAB file and also the written document. Okay. You must also do question number 13 in your MATLAB. Now, the question number 13 is not so hard. I will not be doing this entirely. Okay, so I will just give you an hint on how to solve this, where to start, and what to find. Okay, and then you can find the final answer. Now, among these 12 problems, let me do 3 or 4 problems of different kinds. Now, again, as I mentioned in the previous lab, I will not be doing the same exact problem, but I will be doing a similar kind as an example. Okay, fine. So let's get started. Okay, now the topic is about improper integrals. Now, what do I mean by improper and why is it so important to solve? And why do we require a different method or different approach to solve this kind of integrals? Why don't we do it like we used to do the other problems? I mean, direct integration. Now, let me say this. So when you have an integral, and you have some random function. So this type of integral is called indefinite, right? Indefinite integral. Why? Because we do not have limits, right? Okay. Now, if we have a limit from a to b, some number, f of x dx is called as definite integral. Why do we call it as indefinite and definite integral? That's because, remember, the goal of an integral is to find an area of any geometry. It could be, it need not be a rectangle. Of any geometry, the goal is to find the area between the points, right? Now, when I say integral f of x dx, I am going to find the area of this function, but I do not know from where to where. I do not know the start point nor the end point. That is indefinite. So we do not know the answer definitely, not the exact answer. We do not know the exact answer. Okay. Now, when I introduce a limits to this integral, that is from a to b, that becomes definite integral, right? So the meaning of this is I'm going to find an area between the points a and b, right? That's the meaning. Now, what do we mean by improper integrals? When I say improper integrals, we have a function f of x dx. Now, if you have a limits of this kind from 0 to infinity, this is called as improper. Why is that? So I'm going to start from a or 0. Okay, let us take 0. So 0 makes sense. So I'm going to start from 0 and I'm going to end at infinity, right? So 0 till infinity. And where is that point infinity? No idea about that, right? We do not know how far the integral goes. So it is kind of indefinite as well and also definite because we have 0. So when you have such kind of limits, that is when the geometry or the domain or the interval is not bounded, you have a lower bound. We know the lower bound, but we do not know the upper bound. Upper bound is infinity. So we are not sure what the value it takes. So when you do not have a bounded upper bound, we call that as improper. And there is one more other integral. So when you have from 0 to 1, this is bounded, right? This is bounded interval, 0 to 1, fine. We can find the answer. Now, if your function is something of this type, 1 over x squared into dx, not exactly the quadratic, but imagine you have x in the denominator. This becomes improper. Why? Because when you plug in zero limit to the function, that will give you infinity. So we have 2 points here. Whenever we have unbounded, so whenever we have unbounded limits, when I say limits, the points here, this and this, these are called as limits, right? Upper and lower bound. And whenever the integral or the f of x gives you the answer infinity, then we call this as improper integrals. Yeah. Now, how can we solve this type of integral? Okay, one idea is, let me take an example here. So let us go from 0 to 1. I have 1 over x squared here into dx, just an example. Now, the problem here is when I plug in 0, it is giving me infinity. So I don't want to plug in 0. I want to plug in some other number. But when I plug in that number, the answer should not change much. Okay, so I need that type of number. So how can I define this? So one approach is introducing the limit. So I am saying that there is some number a which is tending to 0, integral from that number to 1 over x squared into dx. Now when you solve this and use the limit, we get some finite number as answer. We will not get infinity. Okay, the reason is that some number is tending to infinity. We are not saying that the number is 0 exactly, but we will take some number which is very close to 0. It can be 0.00001. Okay, 1 over this number will not give you infinity. Okay, you can do this in your calculator if you want to. When you try 1 over 0, it will give you an that is infinity number. But when you try 0.1, it will give you some number. When you try 0.01, it will give you some number, right? So we are going to use that idea here and find the area of the improper integrals. Okay, understood till now? Okay, I will take that as a yes. Fine. Let me solve the problems here. Okay. I hope you can see the screen entirely. Okay. Example number 1. I will go from 0 to 1. This is just an example. Okay. I'm not doing exactly the problems in your lab manual, because students, they try to write like the way I wrote. They don't understand and write it on their own. So I am that's the reason I'm just taking the example problems. Okay, so our limit is from 0 to 1 and the integral is a square root of x. Okay, now the problem here is when I plug in 0 to x, I get infinity. So that makes it improper integral. So how do we solve that? We introduce limit and I say there is some number a that is tending to 0. Why should I take 0? Why not 1? That's because I don't have any problem at the point 1. When I plug in 1 to the function, it will give me answer as 1. So I do not have problem with this limit, but I have a problem with the lower limit, that is 1 over 0. That's why I have to introduce a number which is very close to 0. Okay, now I'm going to solve from 0 to 1, 1 divided by square root of x into dx. Okay, now do not worry about the limit. We just carry on that till the solution. Now let's solve what is the integral of 1 over square root of x. That will give me 2 square root of x from the limits. Oops. Now, whenever we introduce limit, the 0 point will be equal to a. So the number is from a to 1, the limit. So limit a tending to 0. So when we have this arrow mark here, we say a tending to 0. A is not exactly 0, but is very, very close to the 0 value. Now, when I use upper limit minus lower limit, I get square root of 1 minus 2 times square root of a, right? Now, how can we use this limit here? It is simple. You are going to plug, remove the limits, minus. When I say limit a tends to 0, we can use a equal to 0. Okay, we can use that. So I am going to plug in 0 in the place of a. That should give me 2 as the answer, because 2 times 0 is 0, 2 times 1 is 2. So I get 2 as the answer. And that's how you solve improper integrals. Okay, let us do a second problem. Second example. Now I'm going to change my limits from 1 to infinity. Let us take a different function, x to the power of 4 into dx. Okay, now the question is for all of you. This is improper integral, right? Why? I'm saying that this is improper integral. Why is that? So I have a function 1 divided by x to the power of 4. I have a limits 1 and infinity, right? So when I plug in 1 here, I get 1. So this is not a problem. When I plug in infinity in place of x, what do I get? What is 1 over infinity? So in the previous example, we saw that 1 over 0 is infinity. Then what is 1 over infinity? The answer is here. Let me see who will tell me the answer. When 1 over 0 is infinity, what is 1 over infinity? Very good. It is 0. Okay. How is this helpful? Just change the numerator and the denominator. I am asking you what is 1 over infinity. So I will just switch infinity and 0 here. I get 1 over infinity equal to 0. Okay, fine. Now, we know that 1 over infinity is 0. This is a finite number. This is also a finite number. But what is the problem here? Why should this be improper integral? Any idea about this? I do not have any problem with the function because when I plug in the limits here, I get 1 and 0. I'm fine with that. But what makes this improper integral? Okay. So when I explained the improper integrals, I told you when f of x tends to infinity or when you have unbounded limits, that will make an integral improper, right? So here in this example, we have infinity in the upper bound, and that is why we are calling this as an improper integral. Okay, now how do we solve these kind of problems? I mean the same procedure. Limit a tends to what? So when I had 0 to 1 over x to the power of, sorry, square root of x into dx, I plugged in a as 0, right? I told you that a tends to 0. That's because I had a problem with this limit. Because whenever I plug in 0 here, I will get infinity. So I want to avoid this 0 point. And that is why I used limit a tends to infinity, a tends to 0, right? Now, what about this problem? Is this a tends to infinity or a tends to infinity? Should this be a tends to 1 or a tends to infinity? What do you think? Okay, I get two answers. Now, let me say that I'm going to consider it as 1. Okay. Now, do you have problem with this point? Do not worry about the infinity right now. Just think you have some number there. Okay, I have a lower limit 1, and the function is 1 divided by x to the power of 4 dx. Now, can you integrate this? I would say yes. Because when I plug in this limit 1, it will give me 1, right? But when I plug in infinity to this function, I get 0. I am fine with that as well. Now, what can you take as a in such type of condition? You have to take it as infinity. Why is that? Why? Because it is unbounded. That is the main reason. I have from 1, I'm finding area from point 1 to infinity. I do not know where that infinity lies. So I am literally finding some area between these 2 points. But when I plug in infinity to the function, I get area 0, right? Which is not true at all. Agree? Because when I'm planning to find an area between 1 to infinity, how come area be 0? I must have some number between these two, right? So I have to convert this infinity to some number that makes it bounded. Okay, and that's the reason I'm taking a tends to infinity, 1 to infinity, integral 1 to infinity 1 divided by x to the power of 4 into dx equal to limit a tends to infinity. Solve for 1 over x to the power of 4. You get negative 1 by 3 cube root of x, right? And this is from 1 to, I always tend to write infinity. This is 8. 1 to some number a, which is very close to infinity. Which is equal to limit a tends to infinity negative 1 by 3 cube root of a and negative, this makes it positive because upper limit minus lower limit, and I have a negative here, so that makes it positive. 1 divided by 3 cube root of 1, which is 1, right? Okay, now how do you apply the limits? You have to make it equal to infinity, then plug that here in the solution. Okay, now limit, I have to remove the limit here. Now it is negative 1 divided by 3 times infinity, that is cube root of infinity, plus 1 divided by 3 times 1, because cube root of 1 is 1. Agree? Okay. What is the answer now? What is 1 divided by 3 times cube root of infinity? Okay. So we know that 1 over infinity is 0, right? So what is 1 over 2 times infinity? It is 0. What is 100 times infinity? It is still 0. Now, if I take it as square root of infinity, it will not change. So whenever you have infinity in the denominator, the answer is straight away 0. No matter what you have in the numerator, the answer is still going to be 0. Okay. So the answer here is 1 over 3. Why? Because this is 0, this is 1 over 3. So that will give me the answer as 1 over 3. So when you have infinity by infinity, this makes it undefined. That means we have not concluded it as 0, nor it as infinity, it is not even 1. Because the infinity is some large number. So the infinity in the numerator and the denominator, it might not be the same. Okay, and that's why we do not make it as 1. We call that as undefined. Okay. Yes, we will take infinity over some number as infinity or sometimes undefined. Because this is some large number, even if you divide large number by 2 or 3, that doesn't make it a less smaller, right? You want me to write the rules? Let me give you some rules of that infinity. Now 1 over 0 we take it as infinity, and 1 over infinity we take it as 0. When we have infinity by infinity, we say it is undefined or indeterminate. That means we cannot find it. So I will just take it as indeterminate. Okay. So if you have negative infinity, it is the same. We cannot define it because it is everything in terms of infinity, and we do not know what exactly the infinity takes as a number. So when you have infinities in this type, it can be sum, product, or division. We say that the answer is indeterminate. Okay. Okay. Let us come back to the example problem. So this will be the final answer. Okay. Now let us do a last example for this lab. Example number 3. I hope you have taken the answer. Okay. Fine. Now, third type of problem. In example 1, we saw that the limits are from 0 to 1, I had a problem with limit 0. So what did I do? I introduced a number that is tending to 0, right? That was example 1. Now, when I had limit from 1 to infinity, I had a problem with infinity. Agree? So what did I do? I took a number that is tending to infinity. Let me write that here. Limit a tends to 0. And here I had limit a tends to infinity. Now, what if you have 0 to infinity? What do you do then? What will you take limit a tend to? Is it 0 or infinity? Hmm. Yes, it will be infinity. Why? Because it is unbounded. I can have a limit 0. That is not a problem. But I cannot have a limit as infinity. That's the main problem I have to change. Now, you can ask me one question. What if I have 1 divided by x to the power of 4 and I have 0 to infinity? Because when I plug in 1 over infinity, it will give me 0. But when I plug in 0 into the function, that will give me infinity, right? Now, these kind of functions you can still simplify, okay? Uh, for example, you can multiply and divide by x cube. Let's say I multiply by x cube here. Now you can divide this and keep it as x here, and then you can try to decompose the other function. So 1 over x will give me log of x, right? So when I'm plugging log of 0, that gives me 1. So that is not a problem at all. When you have a function here that is giving you infinity as the answer, you can still try to decompose or change the function. Okay, but when you have a limit set to infinity, you cannot change the limit. There is no method that you can that tells you to change the limit, right? So what can we do then? We take limit a tends to infinity. Okay, but you have one u substitution that will change the limits, because if you have limit here, when you put u equal to 1 over x, let's say, so when x is infinity, that u will give me 0. That will work, right? But even if you use u substitution, again you have to convert that in terms of x and apply the same limits that is given for x, right? So that is why we have to take limit a tends to infinity always. We have to somehow limit this boundary to a finite number. Okay, okay, let's see some example on that. So limits are from 0 to infinity. Now the 0 can be 1, 2, 3. You can take from any number also. So 0 to infinity. How can I solve this? This clearly we have to apply integration by parts. It's a product of two functions. So we have to apply integration by parts. I will do that here. So u equal to x. So that will give du by dx as du equal to dx. Now v equal to dv. So dv equal to the remaining term in the function, and that will give me v because I'm going to integrate this function. So this will give me negative 1 over 2 into e power minus 2x. Okay, now I'm going to use the integration by parts formula and apply it to the function. So limit a tends to infinity, unbounded, from 0 to a. Let me apply the formula directly here. U into v. So x e power minus 2x divided by negative 2. The limits are from 0 to a plus 0 to a integral v into u. So e power minus 2x divided by 2 into dx. Okay, now we need to solve this integral. I can do that in the next step. So limit a tends to infinity, x e power minus 2x divided by negative 2 from 0 to a plus integral e power minus 2x will just increase the constant. So that will give me negative 1 by 4 e power minus 2x 0 to a. Okay, now how can I plug this here? This is limit a tends to infinity, a into e power minus 2a divided by negative 2. I will not use zero limit because that will just give me 0. So let me neglect that. And then for this term, upper limit, negative 1 by 4, e power minus 2a, and negative makes it positive. So 1 over 4, e power minus 0. I have negative here. Okay, now let me write the final answer here. Now, all you have to do is plug in the a equal to infinity in the solution. So it is infinity times e to the power of minus 2 times infinity divided by negative 2 minus 1 over 4 e power minus 2 times infinity minus what? What is e to the power of 0? This is plus upper limit minus lower limit. E power 0 is 1. So that will give me 1 by 4 because e to the power of 0 is 1. So this is 1 by 4. So here I get 1 by 4. Now, the problem is, how do you solve this? It is infinity e minus 2 infinity divided by 2 minus 2 minus 1 over 4 e to the power of minus 2 infinity plus 1 by 4 plus 1 by 4. Okay, so I don't have problem with the final term. I have problem with the first and second. I have infinity in the numerator and I am multiplying the infinity to some number. Then how can I make it to some finite number? Observe this very carefully. I have infinity in the numerator, but let me put that outside. I get negative. I'm just putting the negative on the numerator 2 times. I can write e power minus 2 as 1 by e square, right? Negative. I can bring that to the denominator. That will make it 2 times infinity minus 1 by 4. Same goes for this as well. 2 times infinity plus 1 by 4. Now you can see that this is clearly 0 because I have 1 divided by infinity. So this is clearly 0. This is clearly 0. If I'm multiplying 0 to any number, I get 0 as the answer. So the remaining term is 1 by 4. So the final answer for this problem is 1 by 4. Okay. I hope you have taken it down. Now, for the final problem, for the final question, this is for whatever I'm writing in red is for question number 13, the last problem. Okay, I will give you an hint. Now, for question number 13, all you are doing is integrating v of t equal to 1 over square root of t, right? So you're going to integrate this function and equate it to 20,000 and solve for t. You have to tell me what is the value of maximum time. That is what you're going to find out. How do you do that? You're going to integrate the function, equating it to 20,000 and solving for t. That should give you some value. Okay, so let's see how you will be doing it. So that will complete the lab 7. You have to do this in the MATLAB as well as the hand calculations. So whenever you are doing in MATLAB, you might think how to input the limit infinity. So you can use INF. INF stands for infinity. In MATLAB, this is like a built-in command. Okay, so if you have limits from 0 to 1, so we say int f comma with respect to x, say from 0 to infinity, so 0 comma inf. You don't have to put the symbol. So I mean, these are all positive infinity, so I don't think so you have negative infinity problem. So the limits will be inf, just inf. Okay, so this will complete lab 7. So if you have any questions on the previous lab or lab 7, you can stay on the Zoom. If not, you're all good to leave. Happy spring break.